Welcome back. Day 14 of Just Start Programming, the Rust programming language. So for those of you who got to day 14, congratulations. All right, so for today's topic, we're going to learn together writing automated tests in Rust. Yesterday, we learned about annotation, lifetimes, so the scope of the borrow checker, and to annotate lifetimes, you have the apostrophe and a letter, like this, apostrophe A. This is just to refresh our memory. And this is how you write it in the function. So the function name in between the input parameters, the parameters with the ampersand reference, apostrophe A, and a space. And then the same for the returned value. So I think somewhere here there was a reason why you don't have to do it this way if you only have one parameter. I think there were guidelines and rules. Maybe let's go through the rules so that we can remember them, because as for me, I've already forgotten about them. Here. So this one will compile. And this one will not compile. Where was that? Rules. Lifetime elision. Elision. I think let's read through the rules before we start the next topic. Okay, here. The compiler uses 3 rules to figure out the lifetimes of the references when there aren't explicit annotations. The first rule applies to input lifetimes, and the second and third rules apply to the output lifetimes. If the compiler gets to the end of the 3 rules and there are still references for which it can't figure out lifetimes, the compiler will stop with an error. These rules apply to function definition as well as implementation blocks. The first rule is that the compiler assigns a lifetime parameter to each parameter that's a reference. So just like this. In other words, a function with one parameter gets one lifetime parameter. A function with 2 parameters gets 2 separate lifetimes. So A and B, and so on. The second rule is that if there is exactly one input lifetime parameter, that lifetime is assigned to all output lifetime parameters. This one. Just like the first word. First word doesn't use this one. I think there was a reason for that. Okay, then the compiler applies the first rule, which satisfies that each parameter gets its own lifetime. We call it apostrophe A as usual. First word, apostrophe A, apostrophe A. Oh, but this one doesn't have apostrophe A. The second rule specifies that the lifetime of one input parameter gets assigned to the output lifetime, so the signature is now this. Not yet, not yet. Second rule, the rule is applied here. And then for this one where you have two parameters, yeah, so we haven't figured out what the return type's lifetime is. Because which one is the one returning the result? Is it A or B? Because the third rule really only applies in method signatures. We look at lifetimes in that context next to see why the third rule means you don't have to annotate lifetimes in method signatures very often. Lifetime annotations in method definition. So IMPL, so just like instruct, you have the generic type, so that's where you put the lifetime as well. But in the function implementation, there is no need for you to annotate the lifetime. And there are two input lifetimes, so Rust applies the first lifetime elision rule and gives both at self and announcement their own lifetimes. Then because one of the parameter is at self, the return type gets the lifetime of at self. If it's self. Static lifetime. So you can also have a static lifetime like this. Generate parameters, straight bounds, and lifetimes together. Yeah, I think this is the whole application where you have generics, you have lifetimes, lifetime annotation, generic, and then yeah, here this is the function. Okay, let's start with writing automated tests. In his 1972 essay, The Humble Programmer, Edgar W. Dijkstra said that the program testing can be a very effective way to show the presence of bugs. It is hopelessly inadequate for showing their absence. That doesn't mean we shouldn't try to test as much as we can. Correctness in our program is the extent to which our code does what we intended it to do. Rust is designed with high degree of concern about the correctness of programs. But correctness is complex and not easy to prove. Rust's type system shoulders a huge part of this burden. Okay, Rust type system. But the type system cannot catch everything. As such, Rust includes support for writing automated software tests. Say we write function add2 that adds 2 to whatever number is passed to it. This function signature accepts an integer as a parameter and returns an integer as a result. When we implement and compile that function, Rust does all the type checking and borrow checking that you've learned so far to ensure that, for instance, we aren't passing a string value or an invalid reference to this function. But Rust can't check that this function will do precisely what we intend, which is return the parameter plus 2 rather than, say, the parameter plus 10 or the parameter minus 50. That's where tests come in. We can write tests that assert, for example, that when we pass 3 to the add2 function, the return value is 5. We can run this test whenever we make changes to our code to make sure any existing correct behavior has not changed. So it's there to make sure Make sure any existing correct behavior has not changed. Testing is a complex skill, although we can't cover in one chapter every detail about how to write good tests. In this chapter, we will discuss the mechanics of Rust testing facilities. We'll talk about the annotations and macros available to you when writing your test, the default behavior and options provided for running your test, and how to organize tests into unit tests and integration tests. It's all about testing. Okay. How to write tests. Tests are Rust functions that verify that the non-test code is functioning in the expected manner. The bodies of test functions typically perform these three actions. Set up any needed data or state. Run the code you want to test. Assert that the results are what you expect. Okay, set up the data, run the code you want to test, and assert. Always these three. Let's look at the features Rust provides specifically for writing tests that take these actions, which include the test attribute, a few macros, and the should panic attribute. The anatomy of a test function. At its simplest, a test in Rust is a function that's annotated with test attribute. Sorry, I'm back. Attributes are metadata about pieces of Rust code. One example is the derive attribute we use with structs in chapter 5. To change a function into a test function, we add, so sharp square bracket test on the line before the function. This one on the line before the function. So test attribute. When you run your test with cargo test, so we use cargo test command. Rust builds a test runner binary that runs the annotated functions and reports on whether each test function passes or fails. Let's check. Maybe we can do something. Tests, automated, writing automated tests. Maybe we create a new project. Cargo new automated tests. So we know that if we do cargo run, it will build and run. So without annotating it, what will happen? Cargo test. Test result okay. 0 pass, 0 failed, 0 ignored, 0 measured. Well, yeah, because we did not annotate anything, but it will return okay. Maybe that will change once we start creating tests. Rust builds a test runner binary. Okay. Let's see what has changed. 3 main target debug automated test. Where is the test? No, it's not here. Okay, whenever we make a new library project with cargo, a test module with a test function in it is automatically generated for us. This module gives you a template for writing your test, so you don't have to look up the exact structure and syntax every time you start a new project. You can add as many additional test functions and as many test modules as you want. We'll explore some aspects of how tests work by experimenting with the template test before we actually test any code. Then we'll write some real-world tests that call some code that we've written and assert that its behavior is correct. Let's create a new library project called adder that will add two numbers. Okay. Let's come out from here and create a new one. Cargo new adder slash library. Oh no, slash lib. Okay. 3. Okay, so it's lib.rs. Let's open it up. Yep, so it looks different. Okay, so the template, yeah, there's a template where you have a function and then you have CFG test. I thought it was only just test. And then you have test here, it works. Net result, U64 add 2 and 2, assert equal result 4. Okay, try to run this one. Test result, okay, 1 pass, 0 failed. This is here. Test, it works, okay. Successes. Test, it works. Okay. So if we change this to 3, oops. It fails. Because the answer is 4, but it is 3 here. Result is 4. So that's how we check. How about if we put 4.0? It's also 4. Oh, no complaint. Because it's a floating point number, but unsigned 64 as expected. So we need to remove the decimal point. Okay, let's continue. The contents of source lib.rs file in your adder library should look like this. Note that test annotation, this attribute indicates this is a test function. So the test runner knows to treat this function as a test. You might also have a non-test function in the test module to help us set up common scenarios or perform common operations. So we always need to indicate which functions are tests. The example function body uses assert equal. Okay. I think I missed this one. Yeah, test is here. While this one is like it's configuration. Valid forms. Attribute macro. Okay. Function body uses assert equal macro to assert that result which contains the result of calling add with 2 and 2 equals 4. This assertion serves as an example of the format for a typical test. Let's run it to see that this test passes. So this is what we saw. I don't think I saw this one. Cargo test. Oh, it's there. Okay. Cargo compiled and run the test. We see in the line running one test. Running one test. The next line shows the name of the generated test function called test_it_works, and that the result of running that test is okay. The overall summary test result okay means that all tests passed, and the portion that reads 1 pass, 0 failed totals the number of tests that passed or failed. It is possible to mark a test as ignored so it doesn't run in a particular instance. We'll cover that in ignoring some tests unless specifically requested section later in this chapter. Because we haven't done that here, the summary shows 0 ignored. You can also pass an argument to the cargo test command to run only tests whose name matches the string. This is called filtering, and we'll cover that in the running a subset of test by name section. Here we haven't filtered the tests being run, so the end of the summary shows 0 filtered out. 0 measured statistic is for benchmark tests that measure performance. Benchmark tests are, as of this writing, only available in nightly Rust. Okay. Nightly Rust. The next part of the test output, starting at doc_test_adder, is for the results of any documentation test. We don't have any documentation test yet, but Rust can compile and code examples that appear in our API. Okay. Rust can compile any code examples that appear in our API documentation. This feature helps keep your docs and your code in sync. We'll discuss how to write documentation tests in documentation comments as test section. Is it the one that shows up when we mouse over it? Like this. We'll see. Okay, let's start to customize the test to our own needs. First, change the name of it_works function to a different name, such as exploration. Okay. Exploration. Okay. Then what is this? Use super. What is this? Then run cargo test again. The output shows exploration instead of it_works. Should output like this. Let's see. Okay, test exploration. Okay. Now we'll add another test, but this time we'll make a test that fails. Tests fail when something in the test function panics. Each test is run in a new thread, and when the main thread sees that the test thread has died, the test is marked as failed. In Chapter 9, we talk about how the simplest way to panic is to call the panic macro. Enter the new test as a function named another, so your source libr is filed like this. Okay, let's try to type this one. Make this test fail. So how do we create a new test? So sharp test, then function, another, then panic, test. Oh, make this test fail. Fail, fail. Let's run. Okay, so what happened here? Test exploration. Failures. Test another. std out. Test another panicked at librs 17. Okay, 17 9. Make this test fail. Okay. Failed. One passed, one failed. Test failed. To rerun pass -b other -lib. Other. Okay, that is other. Okay. So it failed because panic. We call the macro panic. Okay. So this is what we saw. Not exactly, not unless if you set the rust backtrace equals to 1. So let's do that. Maybe do it here. Set. Is it set or expert? Echo rust backtrace. Okay, so it is set. Then we do a cargo test. Yeah. One passed, one failed. Okay. Shows failed. Two new sections appear between the individual results and the summary. The first displays a detailed reason for each test failure. Where is it? Summary. Okay, this is the summary. Failures. Another, then failed, test result failed. Here. Thread test another panic. At make this test fail. Next section lists the names of all the failing tests. Okay, here, failing test. Which is useful when there are lots of tests and lots of detailed failing test output. We can use the name of a failing test to run just that test to more easily debug it. We'll talk more about ways to run tests in controlling how tests are run section. So it seems like this is just the intro. Let's see. Oh wait, controlling how tests are run. is in the next chapter. Okay. The summary line displays at the end, overall, our test result is failed. Failed. Let's see the command line. Failed. We had one test pass and one test fail. Now you've seen what the test results look like in different scenarios. Let's look at some macros other than panic macro that are useful in tests. Okay. Checking results with assert macro. Assert macro provided by the standard library is useful when you want to ensure that some condition in a test evaluates to true. We give the assert macro an argument that evaluates to a boolean. If the value is true, nothing happens and the test passes. If the value is false, the assert macro calls panic. Oh, okay. If the value is false, the assert macro calls panic. To cause a test to fail, using the assert macro helps us check that our code is functioning in the way we intended. So by default, in assert, if it fails, it will call panic. In chapter 5, listing 5-15, we use a rectangle struct and can hold method, which are repeated here in listing 11-5. Okay, let's put this code in the source lib.rs file, then write some tests for it using the assert macro. Okay, so we can copy this, put it in our code. Rectangle struct rectangle. Then we have an implementation of can hold. Okay, so how do we create a test for it? The can hold method returns a boolean, which means it's perfect use case for the assert macro. In 11-6, we write a test that exercises the can hold method by creating a rectangle instance that has a width of 8 and height of 7. Rectangle instance, width of 8, height of 7. Asserting that it can hold another rectangle instance that has a width of 5 and 1. Okay. Because 8 is bigger than 5, 7 is bigger than 1. So larger can hold ampersand smaller. Larger is here. Okay. Mod test. Oh, why do we have mod test here? Okay, note that the use super asterisk line inside the test module. Mod test. The test module is a regular module that follows the usual visibility rules covered in chapter 7. In the past, for referring to an item in the module 3 section. Because the test module is an inner module, we need to bring the code under test in the outer module into the scope of the inner module. We use a glob here, so anything we define in the outer module is available to this test module. What does it say? Bring the code under test in the outer module to the scope of the inner module. Do we need to create another file? It's still inside lib.rs. Okay, so maybe we can just add this one. But it's named as module test. Mod test. Oh, there's already a mod test. Here. Okay. So what you can do is just copy this one. And append it here. Okay. And then delete this one here. Okay. Oops. Okay. So larger can hold smaller. Okay. So this should return true. How do we run the test again? We go to cargo test. 2 passed, 1 failed. Because of another. Exploration is okay. Larger can hold smaller. Okay. Another failed. So if we comment out 9:15 and the test should pass. We only have 2. This one is okay. This one is also okay. If the values are maybe 8, maybe we put 9 slightly larger. Run. So it should fail. Yeah, fail. But can we also run it from here? Run test. Oh, this is for exploration. This one fails. So let's put it back to, what was the value? 5. And run it again. Okay. So we've named our test larger can hold smaller. We created 2 rectangle instances. So this is the output. It does pass. Let's add another test. This time asserting that a smaller rectangle cannot hold a larger rectangle. Okay, so that's the snippet. This one we need to add. Assert smaller cannot hold larger. Smaller cannot hold larger. So this will fail. Smaller can hold larger. Will fail. Because the correct result of can hold function in this case is false, we need to negate that result before we pass it to the assert macro. As a result, our test will pass if can hold returns false. Can hold, okay, can hold this implementation of can hold. Returns Boolean. So it will return false. False is okay. It can hold. Smaller can hold larger. It becomes false. So we need to invert it. So smaller cannot hold larger. Here. Yeah. Next. Two tests that pass. Now let's see what happens to our test results when we introduce a bug in our code. We'll change the implementation of the can hold method by replacing the greater than sign. Second. With a less than sign when it compares the widths. Less than sign. Running the test now produces the following. Fail. Yeah. Because we have changed the logic. So with, let's make it less than. Than greater than. So it should fail. It is wrong. Smaller cannot hold larger. Already copied the function. Smaller cannot hold larger. Smaller can hold. What is can hold? Width of smaller is less than. Width of smaller is less than. Okay, correct. Then other larger dot width. Okay, so this is true. And height greater than, height of smaller is greater than other height. So this is false. True and false should be false because of and. Returns false. False, you invert false, then it becomes true. That's why it passed. Okay. Cargo test. One failed. It failed. Larger can hold smaller. Larger can hold smaller. I think we haven't changed the logic. Larger can hold smaller. Larger can hold smaller. Assert. Larger can hold. This can hold. Because we changed the logic of can hold. So can hold should be, self should be greater. Okay. Can hold. So larger. Okay, it's larger. itself is greater, height is greater than this two. So this one will return true, and it will pass. If you run only this one, okay. But if you run this, this will fail. Oh, it's also okay. Smaller cannot hold larger. Smaller 5 can hold because it's using the same function, can hold. So if this is smaller, smaller is 5 greater than, so it becomes false. 1 is false, then return is false. Okay, so the answer that is correct is false. And since it will return false here, in assert it needs to return true. So that's why we invert it. Okay, then the test result is okay. Yeah, but if you change this one, if width is less than, width 5 is less than width 8, that's correct. If you change this to less than sign, then height is greater than height. Height of small is okay, so this is false. So if one is false, then the return is false. So this is false. But then we inverted it. It means that it will pass. Yeah, here. Let's see. Again. 1 passed, 0 failed. So assert only interprets true. True, for true it means that it will pass. Okay. I think assert is still a bit confusing. Oh, this one, if you notice, there's an invert here, and then this is Boolean inversion. So if it's false, it will invert it. It will become true. If you see assert with exclamation means a macro, it doesn't mean an invert. Yeah, but that's the Rust language. So we follow the semantic, not semantic, the syntax, yeah, of the macro. Okay, let's see 2 tests that pass. Now let's see what happens to our test results when we introduce a bug in the code. If you change it like this, then the other one, which uses can hold, larger can hold, will fail. Yeah, here. That's what we tried earlier. So if we run both, here from here, failed. 2 passed, 1 failed, and the one that failed, larger can hold smaller. Yeah. So this one fails. So we cannot use the same function, can hold. Because once you change the comparison greater than, less than, then it means different to the other function. Okay, our test caught the bug because larger that width is 8 and smaller width is 5. The comparison of the widths in can hold now returns false. S is not less than 5. Okay, so aside from assert, we have assert EQ, or I think this is assert equal, and assert and E not equal. To perform this task more conveniently, these macros compare two arguments for equality or inequality. They'll also print the two values if the assertion fails, which makes it easier to see why. Okay. So by using this macro, it will print the values also. They'll also print okay. Conversely, the assert macro only indicates that it got a false value for the equal expression without printing the values that led to the false value. Okay, so here in listing 11-7, we write a function named add2 that adds 2 to its parameter. Then we test this function using assert equal macro. Okay, so let's try this out. Let's copy the function. Test add2. So here we use assert equal add2. Okay, so we only specify one parameter, that one plus 2 will return U size. So since we passed in 2, the result is 4, which is equal to 4. So the assert macro takes in two parameters. So it says here that assert equal can have a second form where a custom panic message can be provided. Custom panic provider. Okay, so let's run this one. It should be 3 passed, 1 failed. Yeah, 3 passed, 1 failed. Because it's still the larger can hold smaller, it was failing. Because of the can hold. Here. Okay. Next. Yeah, this one will pass, definitely. We tried that. Adds 2. Okay, so if you says here instead add 3. So it means if we go back to the assert, where did we use this one? Here. So if we put 3, 3 plus 2 is 5. So it's no longer equal to 4. So it should fail. Let's run this test. Yeah, so it failed. But it says earlier that if you use assert equal, it will also show the value. What's the value? Here, assertion. Left equal right. Failed. Left is 5, right is 4. By left, it is the result. right is this one. So they're not equal. Okay. What's the other one? The other one is NE, or not equal. Failed. Yeah. We did the analysis there. Okay, here the assert not equal will pass if two values we give it are not equal, and fail if they're equal. This macro is most useful for cases when we're not sure what a value will be, but we know what the value definitely shouldn't be. It's the reverse. For example, if we're testing a function that is guaranteed to change its input in some way, but the way in which the input is changed depends only on the day of the week we run the test. The best thing to assert might be that the output of the function is not equal to depends on the day of the week. Under the surface, the assert equal and assert NE macros use the operator equal equal and not equal respectively. Okay, so assert equal is equal equal, left and right. Then assert not equal is exclamation equal, or left and right. By left is the first parameter. Here. Right is the rightmost parameter. Okay, I think there's something special here. When assertion fail, these macros print their arguments using debug formatting, which means values being compared must implement the partial equal and debug traits. Okay. Debug traits, we have already covered traits. So traits is, another word for traits is interface in some other languages, some other programming languages. Okay. All primitive types and most of the standard library types implement these traits. For structs and enums that you define yourself, you need to implement partial equal to assert quality of those types. You also need to implement debug to print the values when the assertion fails, because both traits are derivable traits. Okay. Chapter 5. This is usually as straightforward as editing the derive partial, okay, annotation to your struct or enum definition. Where can we apply that one? 5, okay, that is in 5-12. Derivable traits. Where's derivable traits? Traits. Oh, it's in the appendix. Okay. Same book, but in the appendix. Okay, adding custom failure messages. You can also add a custom message to be printed when the failure message has optional arguments to assert, assert equal, assert not equal macros. Any arguments specified after the required arguments are passed along to the format macro. Okay. So you can pass a format string that contains this one, placeholder, and values to go in those placeholders. Custom messages are useful for documenting what an assertion means. When a test fails, you'll have a better idea of what the problem is with the code. For example, let's say we have a function that greets people by name, and we want to test that the name we pass into the function appears in the output. Okay. Greeting This is the function. So we are formatting hello, and then name is here. Okay. And how do we test it? So greeting Carol. Greeting Carol. So it means it should return hello Carol! Exclamation mark. Okay. So assert result contains Carol. So this one is just checking if the name Carol is inside this one. Contains Carol. So it contains Carol, and then it should return true. So this one will pass. The requirements for this program haven't been agreed upon yet, and we're pretty sure the hello text at the beginning of the greeting will change. Hello, pretty sure the hello text at the beginning of the greeting will change. We decided we don't want to have to update the test when the requirements change. So instead of checking for exact equality to the value returned, the greeting function will assert that the output contains the text of the input parameter. Okay, so it's just making an assumption that this hello here could change, so we'll only be testing for the passed in parameter here, if it can be found, which is used by this contains function. Okay, so now let's introduce a bug into this code by changing greeting to exclude name. Okay, so this is clear. Oh, it will not compile also because this one will return a string slice. String. Let's copy this. Greeting. Cargo test. Greeting contains name. It failed. See? Okay, it says that the test will fail because now this one will have hello, but it doesn't contain Carol. Yeah. It will fail. Running this test produces the following. This result just indicates that the assertion failed at which the line assertion is on. A more useful failure message would print the value from the greeting function. Let's add a custom failure message composed of a format string with a placeholder filled with actual values we got from the greeting function. Okay, now greeting Carol. Oh, so this one is the more useful failure message. So we put that over here. Contains Carol. So that will go in the next parameter. There's some special formatting in Rust code. format document. There. Let's undo. Let me save this. And then I think last time we were trying out cargo clippy. Unused variable name. It gives us this messages also never constructed. But did it fix the alignment? No, that will not fix the alignment. So let's make use of Visual Studio Code facility to format a document. Control Shift I. There. So since it will fail, then it should display greeting did not contain name as value was this one. Let's run the test. Where is it? Greeting did not contain name. Value was hello. So it's more verbose. Yeah. That's the one. That's the one we saw just now. We can see the value we actually got in the test output, which would help us debug what happened instead of what we were expecting to happen. Checking for panics with should panic. Okay. In addition to checking return values, it's important to check that our code handles error conditions as we expect. For example, consider guess type that we created in chapter 9, listing 9-13. Other code that uses guess depends on the guarantee that guess instances will contain only values between 1 and 0. You can write a test that ensures that attempting to create a guess instance with a value outside that range panics because it's only 1 and 100. We should do this by adding the attribute should panic to our test function. The test passes if the code inside the function panics. The test fails if the code inside the function does not panic. Okay. Here it's a bit confusing, but from my interpretation, we're supposed to handle not handle panic, but should panic. It should panic. So if it panics, the test passes. Should panic is intentional. The test fails. I mean, we are expecting that it should panic. So the test fails if the code inside the function doesn't panic. So it's the opposite. Okay, let's see. Guess, struct guess, I32, the implementation of guess. Okay. New value I32. That's the input. Then it returns guess structure. If value is less than 1 or value is greater than 100, panic. Guess value must be between 1 and 100. Got value. Guess value. Okay. So if it satisfies this condition, meaning it's beyond the range of 1 to 100, then panics. If not, it will return guess with the value. Value is referring to this one. So should panic is here. Okay, so this is another this is attribute after the test. Should panic. Okay, so let's copy this one. Let's just add it here below. It looks disorganized, but this works in Rust because it's not. It is a compiled. How should we call it? The compiler will compile the code and generate an executable. So it doesn't matter where you put it here. Unlike for interpreted language that you should go line by line. Okay, then how do we write the test? So we'll write the test over here. So it says, we test my memory also. Yes. Then there's another attribute. What's that? Should underscore panic. Okay. Then function. Should be the function. Guess. No. Let's see. Greater than 100. Function greater than 100. So greater than 100. Okay, so it's just the name of the test function. Here, yes, new, yes, new 200. Greater than. Yes, new 200. Okay. Should panic attribute after the test attribute and before the test function it applies to. Greater should panic because should panic is the expected behavior. Okay, so this one should panic. Here, should panic. Okay. But if we remove this, do not panic. Yeah, it will fail. Okay. Why will it fail? Okay, so the expected is it should panic. This one, when you call new, it created the value, it did not panic. So it created the value. It created a value, but was it checking for anything? New. So new, okay, new is here. Okay, so it will just return the value if that's the case. Oh, I'm wrong. So if it's 200, then 200 is greater than 100. Well, panic. It will panic. So it will fail. Yeah, here. It failed. But the intention is we wanted to make it fail. We wanted to make it fail, which is via this panic. And here we anticipate that it should panic. Okay, that's why when we run this again, it will pass. Yeah. So that's the difference. Okay, let's move on. Looks good. Now let's introduce a bug in our code by removing the condition that the new function will panic if the value is greater than 100. Yeah. So if you remove the or value greater than 100, it will not panic. But according to the test, it should panic. So it means that it will fail. Oh, but we have here, this code does not produce the desired behavior. Should panic fail. Yeah. So we can try that out. If you okay, so it's still 200, but in the condition for new, here we are moving this part. So we're not considering 200. 200 is more than 1, so this statement is not executed, so it will not panic, but it will return the value. So if it will not panic, but it should panic, then of course it will throw an error. It should panic, but it did not panic, so it failed. We failed to test whether it's more than 100 because of this. Get to new, and here it should be like this. But if we put in 1 to 100, okay, 1 to 100, less than 1. Can it be negative number? Negative 1. Okay, so it will pass. It will pass because this is true and it will panic. But it should panic. So that is okay. Okay, so let's keep the example like this. Then we move on. We don't get a very helpful message in this case. But when we look at the test function, we see that it's annotated with should panic. Failure we got means that the code in the test function did not cause panic. Tests that use should panic can be imprecise. Okay, imprecise. A should panic test would pass even if the test panics. For a different reason from the one we're expecting. To make should panic test more precise, we can add an optional expected parameter. Okay, expected parameter to the should panic attribute. The test harness will make sure that the failure message contains the provided text. For example, consider the modified code for guess, listing 11-9, where the new function panics with different messages, depending on whether the value is too small or too large. Okay, then where's the should panic expected? Should panic expected is here. Expected, okay, equals less than or equal to 100. Okay, so let's try this one. Copy, put it here. Let's just comment this out. Okay. Then set one. Should panic. Put expected. Set less than or equal to 100. Less than or equal to 100. Put 200 here. Okay. Test. Okay, here guess value must be less than or equal to 100. Less than or equal to 100. Guess the value must be less than or equal to 100. Got 200. But where is the expected? Expected. What's the expected? Expected here. Less than or equal to 100. What does it mean again? We can add an optional expected parameter. The test harness will make sure that the failure message contains the provided text. Make sure that the failure message, okay, the failure message, so panic, less than or equal to 100. Okay, so maybe it checks against this. Let's try to change the message a little bit, then probably it will fail. Less than or equal to, I'll put 200 here. Okay, so it was talking about the expected is actually referring to the error message. So if this is the expected error message, we change it to less than or equal to 200. I think it disregarded the other text. So it will fail. So let's run this. Yeah, so it failed. Okay, here. Here it's clear. Panic did not contain expected string. Panic message, guess value must be less than or equal to 200. The expected substring is less than or equal to 100. Okay, let's do something unexpected. Unexpected, yeah. Let's do something unexpected. So what I will do, I'll just make it 100 because it says that it will contain 100. Then over here, I'll change panic to let me copy it first. Let me remove this, and I'll just put simple as 100. Oh no, let's put it back. And then 200, change it to 100. Why is there a warning here? Okay, because we already had it here. So this one we will comment out. So although the text here is long, okay, then we'll put 100. So this one should be able to figure out that, yeah, 100 is inside the panic. So it should still work. Okay, so let's try that. Yeah, so it passed. Guess value must be less than or equal to 100. Okay, then it did not show the panic statement. Okay, unlike the error earlier, it was clearly checking against panic to contain less than or equal to 100. But if we remove everything and just put 100 here, this also, it should still be okay. Yeah, still okay. Okay, so that's interesting. This test will pass because the value we put into should panic attributes expected parameter is a substring. Yeah, so that's the key information here, substring. Okay, so we jumped ahead with our analysis. Yeah, but I think that's what it was trying to say here. Okay, so let's move on to using result. So this is generic in test. Different types, type T, and I think E is error, maybe. And result is a struct. Is it a struct? Did it mention it here somewhere? Okay, we'll verify in the Visual Studio Code later. So let's try to copy this and then let's put it under here. Let's just append it here. Result. Okay, so what does it do? Rewritten to use result T and E and return an error instead of panicking. Okay, and error, I think we've covered that in the previous chapter, where we have the match and then error handling using result. So I think I need to replace my mouse. It keeps on jumping into another place. Okay, so here it works function now has the result string return type. This one returns what? Returns nothing, right? Yeah. In the body of the function, rather than calling the assert equal macro, we return OK when the test passes and error with a string inside when test fails. So we can do something like this instead of just assert. Writing tests so they return a result TE enables you to use the question mark operator. Yeah, the question mark operator in the body of test, which can be a convenient way to write tests that should fail if any operation within them returns an error variant. You can't use should panic annotation of test result. Okay. Because should panic is only in what? Panic. If you force the function to execute the panic macro. So it says here you cannot mix and match. You cannot use this on tests that use result. To assert that an operation returns error variant, don't use the question mark operator on the result value. Instead, use assert value is error. Value is error. We do this. There's not enough example here. We copied result. No. Yeah, I think we have copied this. Can we test it out? Test it works, okay. Success, it works. Okay, so what happened here? We had add. Add was the adder. Was it adder? Yeah. Adder module calling add function. So since we add 2 and 2 on this exploration, let's go down to this one. Add 2 and 2, result is 4. If result is equal to 4, then okay. Result equal to 4. So we're using wait, does it mean that result is a trait? Is it a trait? Let's see. No, result is a type that represents either success, okay, or fail. Okay. Result is an enum here. Enum. Result is an enum. So this function returns an enum result. Since it's an enum, we need to handle okay and error. So result equals 4. Okay, if not error. So if I comment this out, I think it will complain. Quick fix. Yeah, it's expecting result. And it's looking for error. What if we put okay here also? Okay, it's fine. Okay, so if it is expecting string, so how about if we return string column from? No, I can remove the semicolon. Let's put 2 plus 2 does not equal 4. Expected result is because of the return type. Try wrapping the expression in er. Yeah, so because of result, it's expecting er. Cannot do something like this. Okay. Is value er. Okay, so here you can't use should panic. Okay, so let's try that one out. I think the compiler will complain. Should panic. Yeah, complain. It complains, so I cannot use that. And what else is here? Error variant. Don't use the question mark operator on the result value. Instead, use the assert. Instead, use the assert. Value is er. To assert that an operation returned as er variant. Okay, this is to assert. If you use assert that there's an er variant, so you're checking. So that's why the function here is er. So if it's is er, then I think this one will return true. That's how to write test. Let's move on to the next one. Controlling how tests are run. Okay. Just as cargo run compiler code and then runs the resultant binary cargo test compiler code in test mode and runs the resultant test binary. Default behavior of the binary produced by cargo test is to run all the tests in parallel and capture output generated during test runs, preventing the output from being displayed and making it easier to read the output related to the test results. We can, however, specify command line options to change this default behavior. Some command line options go into cargo test, and some go to the resultant test binary. To separate these two types of arguments, you list the arguments that go to cargo test, followed by dash dash, and then the ones that go to the test binary. Running cargo test dash dash help displays the option you can use with cargo test. Running cargo test dash 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 help displays the option you can use after this through the separator. Those options are also documented in test section of the Rust note. Okay, so let's see. Maybe if I close this, let's use the terminal here. So cargo test, this one will run all the tests. 4 pass, 3 fail. And then what's the other one? Cargo test dash dash. Cargo test dash dash help. Okay, you see the help documentation. Then cargo test. Okay, so this one will display the options you can use. Let's see. Test bench should panic ignore. Okay, so this is how you can specify if the test can be ignored. Sharp ignore. Running with dash dash ignored. Okay. Or include ignored. Include ignored. Ignored. Okay. So where were we failing earlier? Cargo again. Cargo test. Cargo test. It failed. 4 pass, 3 failed. Which one failed? Greeting contains name. It adds 2 and larger. Can hold smaller. Greeting. Greeting. So if I put sharp ignore this, and then here what do I do? Dash ignored. Dash dash ignored. Dash dash ignored. What did it do? Earning 1 test. Greeting contains name. Failed. Cargo test dash dash help displays the options. Help displays the option you can use after the separator. cargo test help. Okay, so here I added ignored, running with dash dash ignored. Okay, and applied to a function which is already attributed as a test. Then the test runner will ignore this test during normal test run. Running with ignored or include ignored will run this test. Okay. So we just need to do a cargo test, then it will ignore one test item. So now we have two. This one was ignored. Oh no, greetings was ignored. But if we do a cargo test dash ignored, it will run it against ignore. What? Yeah. So it will only run the one that was ignored. Greeting. Okay. Running tests in parallel or consecutively. When you run multiple tests, by default, they run in parallel using threads, meaning they finish running faster and you get feedback quicker. Because the tests are running at the same time, you make sure your tests don't depend on each other or any shared state, including a shared environment, such as the current working directory or environment variables. For example, say each of your tests runs some code that creates a file on disk named testoutput.txt and writes some data to that file, then each test reads the data in that file and asserts that the file contains a particular value, which is different in each test. Because the tests run at the same time, one test might overwrite the file in the time between another test writing and reading the file. So it's all because of concurrently trying to access, and maybe the test is writing something into the file while the other tests are reading. The second test will often fail, not because the code is incorrect, but because the tests have interfered. So the tests have interfered with each other while running in parallel. One solution is to make sure each test writes to a different file. Another solution is to run the test one at a time, so sequentially. If you don't want to run tests in parallel, or if you want more fine-grained control over the number of threads you can send the --test-threads flag and the number of threads you want to use the test binary. Take a look at the following example. Okay. That's interesting. Let's see. What do we know? How do we see? Can we see it here? If there's a spike. Paste. Thread 1. That's one failed. One failed. Greetings. How many tests do we have? 1, 2, 3. Okay, 7. 7. Does it mean that if I put 7 here, then it will run everything? One not found. That command not found. Cargo. Yep. Cargo test. What's that? Dash 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 then dash dash test dash threads equals to 1. Test dash thread equals to 1. It's equals to 1 equals to 2. Unrecognized option. So it's just test. Test thread 1. Unrecognized option. Test thread. Is this deprecated of some sort? Cargo test dash dash help. Let's see. What's in here? Yeah. So AI will say option is not directly recognized by cargo task. The dash dash test threads flag is actually an argument passed to the test binary, which is libTest harness, not to cargo itself. Therefore, when you use a recognize option, it means the test runner libTest doesn't recognize. Okay, so it's libTest, not cargo. Cargo test dash 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 thread. Dash dash thread. Not equal, maybe what? Space. Same. The Rust test threads no longer use a single thread. Okay, so this part of the documentation seems to be outdated. 5 years ago. This, okay, August 2024. What's in here? Cargo test. You can solve this by giving each test a unique file or by running tests one at a time like this. sure why it doesn't work. It worked before for them. Uh, Okay, so it says here, by default, all tests are run in parallel. This can be altered with dash dash test threads. flag or Rust test threads environment. When running test, set it to 1. Another general way, okay. Seem broken. Maybe you're doing. I think I have to write a script to cargo test, just one test at a time. There's a bug for it on GitHub. What's the bug? Oh, the bug is for this. I don't know. I don't have the answer yet. Yeah, but I don't think that's crucial at this point in time. So we reset the export? Reset export in Ubuntu. Is unset. Unset variable name. Let's see. Unset threads. Yep. So we cannot unset. Unset -f. Still there. And export a variable in bash. It's only unset. Unset. Just exit. Terminal. Rust anymore. let's ignore this for now. Okay, showing function output. Default, if a test passes, Rust test library captures anything printed to the standard output. If we call print line the test and the test passes, we won't see print line output. We see only the line that indicates the test passed. If a test fails, we'll see whatever was printed to the standard output with the rest of the failure message. So an example in listing 11-10, a silly function that prints the value of its parameter and returns 10, as well as a test that passes and a test that fails. Okay, let's see. This test will pass. Why will it pass? Prints and return 10, but the parameter is 4. Assert equal value 10. Print line, okay, so it returns 10. 10 and 10. 4 was ignored. So I got a value. This test will fail. Prints and return, okay, 8, but it returns 10 here. 5. This code panics. We see the following output. Failed. Test will fail. Test will fail. Failed. Test will pass. Okay. Test will fail. std out. I got value 8. I got value 8 here. Test will fail. Print line. Thread. Test will fail. Panicked. Left, right. 10, 5. Okay. Note that nowhere in this output do we see I got the value 4. I got the value 4 from here, because it will pass. Let's see. Which is printed when the test that passes runs. The output has been captured. The output from the test that failed, I got the value 8, appears as a section of the test summary output, which also shows the cause of the test failure. If we want to see printed values for passing tests as well, we can tell Rust to also show the output of successful test with show output. Okay. Then you need to have this one again. Now I'm a bit doubtful if this one will work also. So let's try it. This is the controlling tests. Let's create a new project. Cargo new. No, well, I think we already had it there. We just use automated test. No, automated test is not a library. Okay, let's create a new one. Cargo new controlling tests slash library like this. That's it. Lib. Okay. cd controlling test code dot. So let's try it out. So just command cargo test show output. Command not found. Show output. What is wrong with this? Cargo test dash dash show output. Even help doesn't work. Cargo test dash help show output. Is it there? It's not here anymore. To pass show output as value, use dash 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 dash. Okay. Oh, what's the difference between the one I copy and paste? I got value 4, I got value 8. Still an unrecognized option. Threads, not thread, threads. Okay. Okay. So if we go back to the other one, what was it? Enter. Okay. 7 tests. 7. How do we know if it ran it with 7 threads? About 2. Meeting explosion reiterate as it works larger, smaller. Yeah, now it's in a different order. Okay, so my mistake. I think I kept on entering thread instead of threads, it seems. So that one is actually working. Rolling test. Let's get back here. I got value 4. Test will pass. So now it's showing this. But if we remove that, I will test will pass. We don't see it shown here. It will only show test will fail. I got value 8. Okay. Let's move on. Running subset of tests by name. Okay. Add 2, add 2, add 3, and 2, add 100. Okay. Cargo test. Running single test. How do we run single test? Cargo test 100. So it's the, I think it's the function name. Filtering to run multiple tests. Cargo test and running 2 tests. Oh, is it because of this? So it helps. It helps to create your function with this. What do you call this? It's not the kebab style. Forgot the term. It's underscore. Okay, underscore style. Let's call it like that. So then you can filter or like this. No, this is the function name of any test function. Yeah. But here, add whose name matches the value will be run. Ignoring some tests unless specifically requested. How to ignore? Yeah, ignore. I think we tried this one earlier. Ignore. Cargo test. Then by default it's ignored. But if you do a -- ignored, then it will include it here. Ignored. So I think we need to be a little bit careful also. Space. Sure, when I copied it, space is not actually space. Or is it because tests, I entered tests instead of test and thread instead of threads? Yeah. Maybe later on I'll review the video and see where I made a mistake. Okay. Then the final topic. Yes. Oh, but we have already crossed the day. Okay, let's just finish this and then let's do chapter 12 the following day. As mentioned at the start of the chapter, testing is a complex discipline. Different people uses different terminology and organization. As community thinks about tests in terms of 2 main categories: unit test and integration tests. Unit tests are small and more focused, testing one module in isolation at a time, and can test private interfaces. Integration tests are entirely external to your library and use your code in the same way any other external code would, using only the public interface and potentially exercising multiple modules per test. Writing both kinds of tests is important to ensure the pieces of your library are doing what you expect them to, separately and together. Unit test. Purpose of a unit test is to test each unit. You'll put unit tests in the source directory in each file with the code that they're testing. The convention is to create a module named tests. Module name test. Okay, I think that's the module that we have here. Here. And this is a library. Okay. In each file to contain the test functions and to annotate the module with CFG test. The test module CFG test annotation on the tests module test. Is it test? Yeah, it's test. Tells Rust to compile and run the test code only when you run code test, not when you run cargo build. This saves compile time when you only want to build the library and save space in the resultant compiled artifact, as the tests are not included. You'll see that because integration tests go in a different directory, you don't need the CFG test annotation. However, because unit tests go in the same files as the code, you'll use sharp CFG tests to specify that they shouldn't be included in the compiled result. Recall that when we generated the new adder project in the first section of this chapter, Cargo generated this code for us. Yeah. Yeah, I think that was generated, but I have overwritten it. On the automatically generated test module, the attribute CFG stands for configuration and tells Rust that the following items should only be included given a certain configuration option. In this case, the configuration option is test, which is provided by Rust for compiling and running tests by using the CFG attribute. Cargo compiles our test code only if we actively run the test with cargo test. This includes any helper functions that might be within this module, in addition to the functions annotated with this one. Okay. Testing private functions. Oh, okay. Private functions. Rust privacy rules to allow you to test private functions. Okay. Let's see. Add to internal adder. Internal adder. And to, okay, calls internal adder. Note that the internal adder function is not marked as pub. Tests are just Rust code and test module is just another module. Items in child modules can use the items in their ancestor modules. Items in child, okay, child module. Which one is the child module? They're the same. In this test, we bring all of the test module's parents' items into scope with the super. Okay. And then the test can call internal adder. Super. Okay, because it's the module inside this one. If we do a super asterisk, we can include internal adder, which is outside this one. Okay. And then the test can call internal adder. If you don't think private functions should be tested, there's nothing in Rust that will compel you to do so. Okay, integration test. Rust integration tests are entirely external to your library. They use your library in the same way any other code would, which means they can only call functions that are part of your library's public API. Okay, so that's the difference between unit tests and this one doesn't say it's unit test. Integration test. Their purpose is to test whether many parts of your library work together correctly. Units of code that work correctly on their own could have problems when integrated. So test coverage of the integrated code is important as well. To create integration tests, you first need a test directory. Okay, you need a test directory. Test directory at the top level of our project directory, next to source. Okay, so source, test. So far, do we have a test directory? So 3. Source, no, we don't have. We can then make as many test files as we want, and Cargo will compile each of the files as an individual crate. Let's create an integration test with code listing 11-12. So we'll have tests. We'll copy this. Test. CD. Let's see. Okay, BRR tests. CD test. And what shall we create? Integration test RS. Correct. Okay. Each file in the test directory is a separate crate, so we need to bring our library into each test crate's scope. For that reason, we add use adder add to at the top of the code, okay, which we didn't need in the unit test. Okay. We don't need to annotate any code in test integration test RS with CFG test. Cargo treats the test directory. Oh, okay. Cargo treats the test directories specially and compiles files in this directory only when cargo test run. Okay, so let's try cargo test. Here, cargo test. Unresolved module or unlinked crate. Unlinked crate. Right? Oh, we're not in adder, we're in controlling test. Okay, cd adder. mkdir tests, cd tests, vi, what was that? Integration test rs. Paste it here. Oops. Run as a code. Then from here, cargo test. Cargo test. Def it adds 2. It adds 2. It adds 2. Yeah, so it will be including the it adds 2 in the test. Although ours has failed, I think the function might have changed something in the function. Okay. Okay, now we know it's there. Yeah, cargo test, dash dash test, argument, integration test. This one we can do. So to isolate cargo test, dash dash test, integration test. There, it only execute this one. Okay, some modules in integration test. Okay, so you can create submodules. As you add more integration tests, you may want to make more files in the test directory to help organize. For example, you can group test functions by functionality they're testing. Okay, so you can organize them. Separating modules. Okay, so it's the same as modules. So I can name common RS. Yeah, test. It's here, test common. Okay, so it's using this kind of approach. I think in the previous chapter, later on, it's quite difficult if we are seeing mod.rs in our visual code. So it's better if we have common.rs instead. It's not a subdirectory. Or you can still write a subdirectory and then common.rs. This could be a util and then you have common.rs. Yeah. Okay. Yeah, so I think we come to the end of writing automated test in Rust. So stay tuned tomorrow. We will be learning an IO project, building a command line program. So we'll do this together. Yeah, let's save that for the next day. Right, so let me end here, and also let me take this opportunity to thank my supporters. Thank you so much. Have a nice day. Bye for now.